Hi, good day everyone. Today I'm going to discuss the Watney-ANOVA process.
Definition of ANOVA. The analysis of variance or ANOVA is statistical model that is used to analyze situations in which we want to compare more than two conditions. It is used to test the null hypothesis that the mean of three or more populations are equal. Background of ANOVA. ANOVA is based on the law of total variance, where the observed variance in a particular variable is partitioned into components attributable to different sources of variation. Analysis involving the investigation of the effects of one treatment variable on an interval scale dependent variable. Purpose of ANOVA is to test difference in mean for group or variables for statistical significance. Null hypothesis equals to mean of population 1 equals to mean of population 2 equals to mean of population 3. While alternative hypothesis used when you have one or more independent variable and only one dependent variable.
Lesson objective is this, but can you just read it by your own, guys? So example 1 here. We want to see if 3 different studying methods can lead to different mean exam scores or not. To test this, we select 15 students and randomly assign 5 each to use a different studying method at 0.05 level of significance. So our step 1 is you just have to add this all in each group. So for example, add this all, guys. 11 plus 10 plus 9 plus 8.5 plus 9.5 is equal to 48. So do the same process to B and C to get the 52.5 and 49. Okay, the step 2 is you just have to get the square root of each group. So what is the square root of 11? 11 is 121, 10 is for 100, 9 is for 81, 8.5 is 72.25, 9.5 is for 90.25. And do the same thing to B and C. So after this, we should get the mean of each group. So 48 divided by 5, which is our sample is 5, is equal to 9.6. 52.5 divided by 5 is equal to 10.5. 49 divided by 5 is equal to 9.8. So after this, we have to compute for the total x squared for each group. We have to add this all, this, and this. 121 plus 100 plus 81 plus 72.25 plus 90.25 is equal to 464.5. And do the same process to this and this. So after completing the total and mean, we need to answer the letters in the right corner here, and their meaning is below the table. So let's start from this. Our K is 3. Why? Because it refers to the each group A, B, and C. So our N is 5, which is the sample, and our big N, which is the population, is 15. It refers about the who participate in our study. The G or the grand mean is you just have to add all the total score. 48 plus 52.5 plus 49 is equal to 149.5. In the summation x squared, you just have to add this all. 464.5 plus 566.25 plus 495 is equal to this, 1525.75. And after this, let's proceed to step 5. So here is the formula of sum of square. So to get the 464.5, we just have to look to the table A first. Here's the 464.5, and the total is, which is this, the 48, the summation of the quantity x squared. So in order to get this, you have to get the 48 squared. 48 squared is equal to 2,304, and divide it to 5 to get the 460.8, and subtract them. Get the 3.7. Do the same process to B. Get this to get this 52.5 is here, total, and the 566.25 is here. So first is compute for the square root and divide them to get the 551.25 and subtract them. First look for this. Get the 49 square root divided by 5 is 480.2, and subtract them to get the 14.8. So since we already have the sum of square, which is the 3.7, 15, 14.8, our table is already complete. So let's proceed to ANOVA table, which is the last part. Let's compute the table. So solve for the total first. Here's the total formula. So we need our letters here, right here, to get this. We need to get their square root first and divide it by 215 to get the 1490.02 and subtract this. So the answer is 35.73. Second is the SL within treatment. So you just have to add the all summation of x squared. It's like what I've done earlier. 3.7 plus 15 plus 14.8 is equal to 33.5. So you just have to add them all. Next is the SS between treatment. This 35.73 is equal to total minus 33.5 is, which is the within treatment, is equal to 2.25. So in degrees of freedom, we have a three formula. So use the letters to understand where we get the 15 and 3. So 15 minus 1 is equal to 14. 15 minus 3 is equal to 12. 3 minus 1 is equal to 2. So that's why we get this. So let's proceed to MS. So here you just have to divide it. 2.25 divided by 2 is equal to 1.125. So here you have to divide the 3.5 to 12 to get the 2.79. In the FS, which is the F statistic, is you have to divide the 1.125 to 2.79 to get the 0.40. So let's proceed to the next. So this is the F table, but in order to get the critical value, we have to look first to the degrees of freedom. Guys, this is the numerator and this is the denominator. So our numerator is the 2 and the denominator is 12. So this is the result, 3.885. So this is the rules, if we will accept the HO or not. So our critical value is greater than the F statistic, so we need to accept the HO or null hypothesis. The F is 0.40 and the F table is 3.88. This is bigger than this. So our conclusion is there was no significant difference in the test scores of the age group. In other words, there is no difference in in their characteristic of population. So that's all. Let's proceed to the example 2.
For example number 2, it demonstrates how many children enjoy flavored chocolate, strawberries, and cheese ice cream. At a 0.05 significance, perform an ANOVA test to see if the average of flavored ice cream are equal. For our step 1, compute total sample. So each column, we will add all of the numbers. So the first column is equals to 30, and for the second is 38, and for the last column is 18. For step 2, let's compute for mean. So 30 divided by 5 is equals to 6. For the second column is 38 divided by 5 is equals to 7.6, and for the last column is 18 divided by 5 is equals to 3.6. So for step 3, we will compute for the x squared of each group. The summation of x squared in the first column is 206, for the second column is 324, and for the last column is 88. So for step 4, after completing the total and mean, we need to answer the letters in the right corner. K stands for the 3 groups we have, and the small n is equals to 5 because each group has 5 numbers, and the capital N is the total of the 3 groups, so it is equals to 15, and for our G, it is the total of total each column, so 30 plus 38 plus 18 is equals to 86, and for the summation of x squared, it is the summation of x squared each column, so 206 plus 324 plus 88 is equals to 618. So for the step 5, let us solve for the SS. So here is the formula we are going to use. So with the use of our formula, we ended up in 206 minus 180 is equals to 26. The next one, we ended up in 324 minus 288.8. So it is equals to 35.2. For the last one, we ended up in 88 minus 64.8. It is equals to 23.2. So after those steps, we already completed the first table, so we will proceed to another one. So first, we will solve for the total. So it ended up using the formula with 618 minus 493.07. It is equals to 124.93. So for next, let us solve for the SS within treatment. So to get this SS within treatment, we will add all the SS in the first table we used. So 26 plus 35.2 plus 23.2 is equals to 84.4. And now, let us solve for the SS between treatment. So using the formula, we will just subtract the SS total with the SS within. So it ended up in 124.93 minus 84.4. So it is equals to 40.53. Now, let us solve for the degrees of freedom. The first one is the DF total. It is equals to n minus 1, or simply 15 minus 1 is equals to 14. Next, for the DF within, we will use the n minus k, or is simply 15 minus 3 is equals to 12. And for the DF between, we will use the k minus 1. So it is simply 3 minus 1, so it is equals to 2. Now, we will solve for the MS between. Just follow the formula and we will get 20.265. And for our MS within, we will get the 7.03 with the use of our formula. FS, we will use the formula MS between divided by MS within. so we got 2.88. So after completing the table, we will now look for the F table with the use of DF between and DF within. So it is 3.89. And for the last part, let's compare for F statistics, or the computed value and critical value from the F table. Our F is equals to 2.88, and for our F table we have 3.89. For our conclusion, there was no significant difference of ice cream. So, the critical value is greater than F statistics. It means that we will accept the H, or also known as null hypothesis. That's all. Thank you.
Question 3. Below are the ages that females get pregnant in Manila, Cavite, and Batangas. At a 0.05 level of significance, perform an ANOVA test to see if the average age of pregnant in these three places are equal. We need to add all of the numbers by column, so we end up getting a total for each column. For column A, we have a total of 105, column B, total of 100, and for the last column, we have a total of 107. 105 divide 5, so we got 21. Do the same thing in column B and C. So for B, we got 20, and C, we got 21.4. We need to get the square root of all numbers and add again to get the total. For square root of the first column, we have a total of 2,215. The second column, we have 2,016. And for the last, we have 2,323. We will skip this part because Mary explained it a while ago. K is 3 because we have 3 groups or columns. Small n is 5 because we have 5 numbers each columns. Capital N is 15 because it is the total of how many numbers are there in 3 columns. And G is 312 because it is a sum of all the total. Let's solve for the SS. We have a formula here that we need to follow. That's why we end up with an answer of 10. Do the same process here, so the answer is 16. Here also, what's in the formula, so the answer is 33.2. Our SS is 10, 16, and 33.2. Last part, the ANOVA table. Just follow it to get the answer. We need to add all the SS, and then we already have an answer for within treatment. Follow the formula. Mary explained it also earlier, so we have 2, 12, and 14. 5.2 divided by 2 is equal to 2.6. 59.2 divided by 12, and the answer is 4.93. To get the frequency, we divide the 2.6 and 4.93, and the answer is 0.53. Here's the table that we need to find the 12 and 2, and they meet at 3.89. F is equal to 0.53 and F table is equal to 3.89. For our conclusion, there was no significant difference in ages that females get pregnant.